Assalamualaikum and very good morning. So today our group will explain about the gyroscope open-ended experiment. So before we start, let me introduce our members first. So we have Ghassan Hossam Hamid, Muhammad Irshad bin Muhammad Azwardi, Amin Najmi bin Yusaini, and myself Nurfana binti Muhammad Daus. So let's start our presentation. So the first is introduction. So a gyroscope is a device to measure or maintaining orientation based on the principles of angular momentum. Basically, it is a spinning wheel on an axle. Once spinning, it tends to resist changes to its orientation due to the angular momentum of wheel. Gyroscopes are built with two properties which are rigidity and precision. So conventionally, it contains three vectors, torque, spin, and precision that oriented with respect to each other according to the right-hand rule. So next is theoretical background. So fundamental equation of gyroscope behavior is given by torque equal to angular momentum divided by time, and we will get moment of inertia multiplied by angular acceleration. So when all vectors remain constant or in steady precession, we get this formula, and when theta equal to 90 degree, so we get T equal to momentum of inertia divided by multiplied by speed of precession and speed of spin. So and it gives a moment of inertia equal to weight times by radius. So next I will pass to my friends.
So for the equipment procedures, let's see the video.
Okay, Assalamualaikum to Dr. Azim and also my fellow friends. My name is Muhammad Syed bin Muhammad Azwardi, and I will continue the presentation with the equipment and also with the procedures. So first of all, I will show you the equipments that we use during the experiments. So first of all, we need the gyroscope and also the stand of the gyroscope. And then we need the 40 centimeters of strings that will be used to spin the gyroscope. Next, we need the 1 gram of plasticine. And then we need the box with some angle of incline beside the box. And then we also need the stopwatch to record the time taken. And lastly, we need the tape that will be used to tape the stand of the gyroscope on this surface of the box. So that's all for the equipments. So let's proceed with the procedures of the experiments. Okay, firstly, we insert the string into the hole that located in the middle of the shaft, and once it's inserted, we will coil around it, and then we will pull off the string to make the flywheel of the gyroscope spin. So for experiment number 1, we will change the speed of the orientation by changing the number of coil. So first we started with 20 number of coil, and then the time taken for the gyroscope to fall to the ground is recorded by using the stopwatch. And then the experiment is repeated by using 30 and 40 number of coil. So for experiment number 2, we will use plasticine that will represent our mass in this experiment. So the first plasticine is equal to 5.50 gram, and then we will locate it at the top of the shaft. The number of rotation is fixed to 20, and then we will let it to spin on the stand of the gyroscope. So the time taken for the gyroscope to fall to the ground is recorded by using the stopwatch. And then this experiment is repeated by using 10.25 gram and lastly 15.10 gram. So for experiment number 3, we will only use one plasticine to locate it at the 3 different locations. So first at the top of the shaft, second at the middle of the shaft, and lastly at the bottom of the shaft. So we started the experiment by locate the plasticine at the middle of the shaft, and then we let it spin on the stand of the gyroscope. So the time taken for the gyroscope to fall to the ground is recorded by using the stopwatch, and then it's repeated at the different location.
So the first experiment is to examine effect of spin speed on precession speed. So we have these parameters, And at the right side of the slide, show the other dimension that needed to calculate the speed of precession. So at the right side, it shows the formula that we use to calculate the precession speed, and we get as the tablet data. So next. So for the second experiment, to examine effect of mass on precession speed. So the variable of the experiment is mass of plasticine and time taken. So we decided to have 5.5 gram, 10.25 gram, and 15.1 gram for mass of plasticine. So at the right side of the slide show the other dimension that needed. So then after we calculate it, we get the precession speed, which are 58.3333 for 5.5 gram, 62.26 for 10.25 gram of mass of plasticine, and 66.28 for mass of for 15.1 mass of plasticine. So the last experiment is to examine effect of location of mass along the shaft on precession speed. So the location, we decide to put the mass on the top of shaft, middle of shaft, and bottom of shaft. So we get this time taken. So other dimension that needed is diameter of this, mass of gyroscope, length of string, fixed angle, and fixed mass that shown at the right slide, at the right of the slide. So next.
So for this discussion for the experiment one, this graph shows the number of coil against the time taken. So when we increase the time, the second graph is the graph of angular velocity against the precision of speed. So next slide. So for the experiment 2, this is the graph of the mass against time taken. So the second one is the graph mass against the precision speed. So the next. So this is the graph for the experiment 3, which is the location against time taken. So next. So based on the graph and result obtained for experiment 1. So when the number of coil increase, the angular velocity increase, but when the number of coil increase, the precision speed decrease. So when we put the number of coil is 20, the angular speed is 12.2 radian per second. The precision speed is 53.78 radian per second. But when the number of coil is 40, the angular speed is 14.5 radian per second, and the precision speed is 45.13 radian per second. This shows when the number of coil increase, the angular velocity increase, but the precision speed decrease. So for experiment 2, when the mass at to gyroscope increase, the precision speed also increase. When the mass add to gyroscope is 5.5 kilogram, the precision speed is 58.33 radian per second. When the mass add to gyroscope is 15.1 kilogram, the precision speed becomes 66.28 radian per second. So this shows that as the mass add to gyroscope increase, the precision speed also will increase. So next slide. So the final experiment is experiment 3. So the time taken for the gyroscope is different for different location of mass along the shaft. So the location mass of the bottom record the longest time taken, which is 16.39, and the lowest was recorded at the top, which is 12.89 seconds. So the overall result, however, has some errors due to the malfunction of the gyroscope, which the center part of the gyroscope can be easily detached. This error will reduce the accuracy of the experimental result.
Yeah. In conclusion, we have done 3 experiments using the gyroscope exam. The effect of spin speed and the mass and location of mass along the shaft on the precision speed. The gyroscope has many practical uses. In fact, many devices with spinning wheels exemplify a gyroscope. In addition, many objects benefit from gyroscope motion, such as bicycle and motorcycle wheels. Yeah.
So, so that's all from us. Thank you.